I made a 3D game engine. Remember in my last video when I said while I was playing some Minecraft, I thought to myself, I wonder how these graphics work, and then I made an entire 3D ASCII engine? Yeah, well, I did that again, but a lot better. Of course, it took me 2 weeks this time, but we really don't talk about that. It has many features such as a 3D renderer, an entity component system, a collision system, and much more. Well, I don't want to waste too much of your time, so let's get into it. Anyway, those are some of the things that I made with my game engine, and the first thing is the one that I'm most proud of. It only takes about 190 lines of code using my game engine, and that's with a whole lot of unnecessary comments and bloat, so in reality, it'd probably be more like 100 lines. A lot of these lines are pretty cool, so let's take a look at the most important ones. Alright, so here is the code for the little demo that I was talking about. The first thing you have to do to use my game engine is you literally just include the engine. Or like, if you also wanted to, you make sure you include the engine first, and then you'd include everything else after, like that. But you always include the engine first, before any other things. And then if we move on to the next things here, you can see that we have a struct called player movement, and it extends publicly CG component, which is the namespace. CG is the namespace for my game engine. And then you can see that there's a virtual void start and a virtual void update. Now, these are the functions that will be called on the component. Start is called in the start of the game, obviously, and then update is called once per frame. They have to be virtual or else they don't work. And then we're just going to break down just simply some other stuff. We also have another component here, as you can see. It just renders, it's just the profiler. And then you can see we have a CG window, and then we use the CG create window function at the 16:9 aspect ratio with the name of game engine. This false here means that it's not full screen, and this true here means that it is VSync. Then we create an engine here that will be used. Then we get a pointer to the input manager, so we can get input. Then we get a pointer to the profiler, so we can profile stuff. Then we init this separate namespace called CG basic shapes. Now, basically, what basic shapes does is it allows us to have some built-in shapes like cubes, panels, and planes. Just simple stuff like that. The next thing you can see is that we're gonna load in some shaders. We actually don't need this one, so let me just take that out real quick. But you can see we have the normal shader and we have the UI shader, so you just load in the vertex and fragment for each of them using the CG load shaders function. And then the next thing you have here is we just create a simple camera with a normal shader. And then we load a texture called brick.png in this file path. And then we make a material called brick, which uses the brick texture. We kind of do the same thing for the skybox here, but instead of just using the texture as the input, we say its color, which is white, and then this false here, which means that it is not lit. And then we load a font called Roboto, which I'm sure we all know what that is. It's just the best font. And then we make a text material, which is a UI material. And we use Roboto, and we use a color, which is mostly green. Now stuff's about to get interesting. This is where we create our first entity, which is an object in the world of the game. So as you can see, this entity is called player. And the first thing we do on this player is we make a player movement, which was the component that we created up here. And then we use an init function on it with the input pointer and the FPS pointer, because that's the pointers that it has to use. So as you can see, it gets the inputs here, and then it sets these variables, and then it just is used over here. And then to add a component to an entity, you call entity.addComponent and then a pointer to the component, because you know, pointers. I totally understand pointers. I don't throw them everywhere. Yeah. And then we just add the camera to the player, which is a component. And then we make a little collider on the player, which is just this. Technically, that collider should have a type. which is just base, but I forgot to do that. Generally, the type of your collider is just going to be an AABB, but it doesn't really matter. I'm just going to make that a sphere real quick. Forgot to do that. And then we add the component to the player, again, a pointer to the component. And then we use the engine.add entity, and then a pointer to that entity, and that adds that entity to the world of the game. And then we kind of do that same general stuff for a directional light. But as you can see here, we have this transform on an entity. And we say entity.transform, and then we're going to say .translate. And then this will move it around in 3D space. You can either pass in 3 floats, or you could even pass in, if you wanted to, a vector 3 like that. And that would allow you to move something around the world. And then we have an ambient light. We just make a color with it. Nothing special. Here's the skybox, but as you can see, it doesn't actually. It's its own component because skybox rendering is a bit different than normal rendering. And you can see we're using that basic shapes namespace that we talked about a little up here to get the skybox mesh, which is just an inverted cube mesh with a little bit different texture coordinates. And then we use the skybox material, a pointer to it, of course. And then we add a component to the skybox component. And then we transform.rotate, which works in radians. Then you can pass in a vector 3 there, and then we just add the skybox to the engine. Now, this is what we use to render the cubes. This is how we add them to the world. Now, what you can see that we're actually only creating one entity called IR, which is short for Instance Renderer. Now, the reason there's only one entity here and not, well, a million of them is because it's way better for performance. And if you don't know what Instance Renderer is, it basically, you create a buffer of data, and then you pass that in. But it's not just one mesh, it's that buffer contains all the meshes, and then you render that. That's actually a batch render. Instance render is more like you pass in all the model matrices, and then you do that. They're very similar. And then you can see we just pass in a CG basic shapes cube again, and then we pass in the brick material that we defined up here. And then if we go back down, you can see that we just add that instance renderer component. And then we have a vector of GLM map4s. And then we make some transforms, and we translate, rotate, and scale these transforms randomly, which is how we get that output in our screen. And then we add that transform.getMatrix function, which is a nice little function I added to the transform component, so that you're able to just get a matrix out of it if you don't want to just use the transform component. And we set the instance of the instance renderer. And this instance function basically just tells the instance renderer, hey, I want you to buffer this data to the instance buffer, so do that, and then it does. And then we're just clearing this for memory management. Then we add it to the engine. Now here's the UI stuff up here. You have to create a canvas for UI, as opposed to creating a camera or an entity that holds the camera. And then we just create a canvas component and add it to the entity, and then we add that entity to the world. And then you can see we're making a text component. Now, I don't want to tell you how long it took to get text rendering working, but it was one of the longest things before instance rendering. As you can see, we have a text renderer component right here, and we pass in a UI, as you can see, a UI mesh, and then we pass in a UI material. This UI material has to be type font. You don't really have to worry about that. You just pass in a font to the UI material, it does that all for you. And then we just add the component, and then we add it to the engine. And then we set the text of the text renderer to however many cubes there are, plus a string that says texture cubes instancing test. And then we just move it around, and these positions, 25, this is not world space, this is actually like pixel space on your screen, starting from the bottom left of the screen, which would be like down here. And then here we create the FPS GUI renderer, or FPS GUI, just UI, FPS UI renderer. And then we add the FPS renderer component that we created up here. We kind of skipped over that because it's not much different from anything else. And then we just add it, all that stuff. And then here we use the CG audio class to play some audio, just this little background soundtrack, and then true means that it does loop. And then we use engine.start, which builds like all the stuff for the engine, gets it all ready. And then the engine.run function, it loops everything. As opposed to in your main code doing while like true or something, and then engine.update, which is also a function you can do if you want a little bit more control over everything that happened. Then you could totally do this way, but I like doing it this way instead, because with just calling one function, you run the whole thing. And then we just return 0 because it's an int function. So that's how to make a demo that renders 1 million cubes with my engine. And if you'd like to download the demo or the source code, you can download it from my itch page. Of course, I kept most of the progress that I was making with my engine, so let's take a look at the history of the engine. So here's the first triangle I rendered with my engine. Here's the second triangle I rendered with my engine, but it's different because it's abstracted into the engine. Here's me rendering a quad, but it's moved off to the side, and it's actually using a mesh renderer component. Here's me rendering textures for the first time in my engine. Here is some directional plus ambient lighting, but there's no specular lighting. Here's 1,200 cubes being rendered at 30 FPS. Here's when I got model loading and skyboxes to work in my engine. This is when I got GUI integration to work. This is a little FPS monitor. There's a black square in the middle of the screen, and that's actually a custom GUI that I was working on. Here's when I got text rendering to work. This took me way too long, and I don't know why it took like 2 hours to get working. This is when I abstracted all of the text rendering and UI rendering into a class. This is rendering 2,500 cubes at 31 FPS. This is rendering 250,000 cubes at 7 FPS. Here's 2,500 cubes again, but this time at 142 FPS. Here is some broken instance rendering. I don't really know what's going on here. It just kind of was one of the bugs that I came across trying to get instance rendering to work, that took a while. Here's me rendering 2,500 cubes again, but this time at 142 FPS. This is me rendering 1 million textured cubes at 144 FPS. It's actually more around 70 on average, but you know, the first frame is 144. Here's some basic AABB collision. Here is sphere collision. Here is sphere to AABB collision. And then here is sphere to rotated cube collision. Here's the final thing I did with my engine. It's running a lot faster now, which might not make sense because it's only 50 FPS, and the last time I did 1 million cubes was 70 FPS. But that was really jittery and kind of lagged a lot, but this one feels a lot smoother, which is going to be a lot better for 3D games. So, after knowing a little bit more about my game engine, let's see how it works on the inside. Remember when I showed off the features of my engine? Now I'm going to highlight the most important ones. These connect together like this, and we'll input a W with the keyboard to see what happens. So, basically what happened there was the keyboard sends the system the input, and we get the input from the system with the input manager, and then the entity component system uses that input to move a cube upwards. After that happens, it's time for graphics. The entity component system generates a model matrix for the mesh and sends it to the GPU. Then, the GPU does some magic to make a frame buffer, and finally the window system displays all of that to our window. Now, let's move on to the obvious. I'm only 14. I'm not coding graphics APIs normally, unless they're made of ASCII characters, of course. So, I had to use some libraries. Also displayed on screen are some video and website links to help you learn OpenGL for yourself. All of these links are also in the description if you would like to visit them. Thank you all so much for watching this video, and for all 3 of you that watched this far, it means so much to me if you liked this video and subscribed to this channel. This video took me a total of 2 weeks to film and 4 days to edit, so it was by far my hardest worked video. I will see you all next time. Bye.